Among the most studied molecules in biology, p53 is often called the guardian of the genome, and for good reason. It plays a central role in protecting cells from malignant transformation. But p53 is far more than a tumor suppressor. It is a master regulator of cell fate decisions, coordinating a complex network of responses to stress, DNA damage, nutrient availability, and aging. One of its less recognized but increasingly important roles is in regulating autophagy, the cellular recycling system essential for maintaining homeostasis and longevity. Through its control of autophagy, p53 serves as a critical link between cancer prevention and the aging process. p53's involvement in autophagy is nuanced and context-dependent. Under conditions of mild stress or nutrient deprivation, nuclear p53 can activate autophagy by upregulating genes like DRUM1, damage-regulated autophagy modulator 1, and AMPK, AMP-activated protein kinase, which promote energy balance and cellular cleanup. This form of autophagy protects cells by clearing damaged mitochondria, reducing reactive oxygen species, ROS, and preventing the accumulation of misfolded proteins, all processes that suppress tumorigenesis and extend cellular lifespan. In this sense, p53 acts as a metabolic gatekeeper, triggering autophagy as a preemptive repair mechanism rather than waiting for damage to reach a critical threshold. However, the role of p53 is not universally activating. In the cytoplasm, particularly under conditions of persistent stress or oncogenic signals, p53 can suppress autophagy through interactions with autophagy regulators like FIP200 or mTOR. This dual role, autophagy inducer in some contexts and inhibitor in others, illustrates how p53 fine-tunes the response to ensure that autophagy remains adaptive rather than excessive. Too little autophagy can lead to cellular dysfunction and cancer. Too much, especially in already stressed or energy-depleted cells, can trigger cell death or tissue wasting. p53 helps maintain this delicate balance, which is essential for both cancer resistance and healthy aging. As organisms age, p53 activity tends to increase, in part due to the accumulation of DNA damage and other cellular stressors. This heightened activity can be beneficial, enhancing autophagy and promoting the clearance of precancerous cells. But in the long term, chronic activation of p53 can contribute to stem cell exhaustion, tissue degeneration, and the onset of cellular senescence, a hallmark of aging. In this way, p53 embodies the classic trade-off of evolutionary biology. It defends against cancer in youth, when reproduction is paramount, but may accelerate aging later in life, when the cost of hypervigilance becomes more apparent. The challenge for anti-aging and cancer therapies is to harness the benefits of p53 without unleashing its drawbacks. Efforts to pharmacologically modulate p53, either by enhancing its tumor suppressive functions or tempering its pro-aging effects, must account for its interactions with autophagy. For example, restoring p53 activity in cancers where it is mutated or lost can reinstate autophagy and cell cycle arrest, offering a route to treatment. Conversely, inhibiting overactive p53 in aging tissues might preserve stem cell pools and reduce degenerative decline, but could increase cancer risk if not tightly controlled. The centrality of p53 in regulating autophagy, tumor suppression, and aging highlights its role not just as a molecular switch, but as a dynamic integrator of cellular priorities. It assesses damage, energy status, and external signals to guide cells toward survival, repair, or removal. Autophagy is one of its most powerful tools in this balancing act, allowing the cell to adapt, rejuvenate, or self-destruct depending on what the organism needs most at a given time. In the end, p53 does not simply protect the genome. It protects the entire organism by mediating between short-term survival and long-term health. Its governance of autophagy is a testament to this role, ensuring that cells stay clean, functional, and poised to respond to challenges. Understanding how to modulate this axis with precision could open new frontiers in both cancer prevention and healthy aging, turning the guardian of the genome into a steward of longevity.